Hello, math students, summer school. This is Math 2 Spring, Week 1, Day 1. Activity 2.5 was one of those things I was supposed to cover in class time and didn't get to it. So I'm going to try to just work an example for you now and hope that it helps you as you do your mastery of math. The title is Absolute Value and Compound Inequalities. So here we have a strictly less than equal to sign in an example. This is, if you happen to have your textbook, Module 3, page 25, example 1C. And I thought I would just try this one and work it for you. So we have a one-dimensional number line. It's marked off by 2's. So it goes -10, -8, up to 0, up to +10 in 1 millimeter increments. And the equation says here, solve, actually. It says solve the linear absolute value inequality, and it's given as the absolute value of the expression -5x plus 8, and then outside that expression plus 2 is strictly less than 25. All right, let me see if I can do it right on the first try. My first step, excuse me, would be to subtract 2 from both sides. That doesn't change the inequality. If 5 is less than 6, then 5 minus 2 is still less than 6 minus 2. So I can subtract 2 from both sides and write this thing as the absolute value of -5x plus 8 is strictly less than 23. Okay, this is progress. When we have absolute value, there are two possible solutions. One is the positive and the other is the negative. For the positive one, we just basically pretend that the absolute value sign is a parentheses. And I'm going to write it without the parentheses. So this becomes -5x plus 8. I'm not writing the absolute value signs. I'm taking the positive contents here, is strictly less than 23. Now go solve for x. My next step would be to subtract 8 from both sides. So the left becomes -5x is strictly less than. So now what is 23 minus 8? And I get 15. For my next step, you need to be a little bit careful here. You would say, oh, let's divide by -5. However, when you divide by a negative number, the inequality flips direction. So for example, if you agree with me that 1 is less than 2, if I were to divide both sides by -1, then this becomes -1, and this becomes -2. Is it true that -1 is less than -2? Think about that for a moment. Let me show you on the number line. Every number that's to the right of some other number is greater than the number to its left. The numbers to the right are always greater than the numbers to the left. So if I plotted 1 and then looked at 2, I see 2 is to the right of 1, 2 is greater than 1. When I look at -1 and -2, so my pen's at -1, my finger's at -2, -1 is to the right of -2. -1 is greater than -2. And so the inequality flips direction. 1 is less than 2, but when I divide by a negative number, the inequality flips direction. -1 is greater than -2, or equivalently, -2 is less than -1. So when I divide -5x is strictly less than 15 by the quantity -5, be careful. -5 divided by -5 is 1, and so we have x. The inequality is being divided by a negative number, so it flips direction. Instead of being less than, it now becomes greater than. 15 divided by -5 is -3. So my first solution is x is strictly greater than -3. In a compound inequality, if this were greater than or equal to, I would represent that with a filled in circle at x equals -3. But this says not greater than or equal to, it says strictly greater than. So I represent that numerically with an open circle at the location of x equals -3. I'm going to do it in very large font so you can see that's at x equals -3, halfway between -2 and -4. And strictly greater than means it goes to the right, increasing from -3. So that's part of the solution. But now let's go get the other part. To find the other solution, we treat the entire inside of the absolute value sign as if it were a negative quantity and write it with a minus sign on the outside to flip it from negative to positive. Replace the absolute value symbol with parentheses. So absolute value of -5x plus 8 becomes negative, open parentheses, minus 5x plus 8. Don't mess with the signs on the inside. Close parenthesis replaces the absolute value symbol. And no, the inequality doesn't flip in this situation. We're just replacing the left expression with its other possibility. So it's still, whoops, I'm sorry, writing the original expression, plus 2 is still strictly less than 25. So this is the other possible solution to the expression that we now need to go get. I would still do, as my very next step, subtracting 2 from both sides. What I do on the left, well, for me personally, I would like to distribute this minus sign. A negative times a negative is a positive. So I'm going to do 2 steps at once. A negative times -5x means positive 5x. I'm distributing that minus. A negative times plus 8 makes it minus 8. The second step I'm doing right away is I'm going to subtract 2 from both sides, just like before. Because I'm subtracting or adding, that doesn't change the orientation of the inequality. So it's still less than, and this still becomes 23. Next step, I would personally add 8 to both sides. On the left, I have 5x. Again, addition and subtraction doesn't change the orientation of the inequality, so is strictly less than. And now I go 23 plus 8 is 31. Next step, I would divide both sides by 5. On the left, I have x. Now I'm dividing by a positive number, so the inequality doesn't change. Just as 1 is less than 2, 1/2 is less than 2/2. So it's still strictly less than. And this is a weird number. This is 31/5. Oh, how lucky for us to have a fractional number. If you like, you can express this as that's it being expressed as an improper fraction, and that is equivalent to taking 30, dividing it by 5, which is 6, and having 1/5 left over. So 6 times 5 is 30, plus 1 is 31. So 31/5 is equivalent to 6 1/5. X is strictly less than 6 1/5. Now go graph it. Back here on this number line, 6 1/5 is 1/10 of the way from 6 to 8. So it's almost right on top of 6. It is strictly less than, so I draw it as an open circle at 6 1/5, and it's strictly less than. So here's a situation where the entire solution spans x is strictly less than 6 1/5, while it is strictly greater than -3. So in one little tidy expression, here it is in written form, the solution. Here it is in graphical form on a one-dimensional number line. I don't know. I suppose I could do one more example. Let me set it up. Ooh, 1A through E. Ooh, how about E? Okay, so I'm going to set up the number line. You're going to have to be patient while I draw this thing again. Ding, ding, ding. Try to add some sound effects when you do calculations, particularly math ones that sound like doot, 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 beep, beep, beep. That's one of my favorite ones. I see they set up their number line by twos. They go from -10, -8, -6, -4, -2, 0, 2, 4, 6, 8. Who do we appreciate? All right, so you didn't see what I drew at all. This is going to be 1E on page M3-55 if you have access to the book. And the expression says, solve x, I should say the absolute value of the expression x plus 5 inside absolute value symbol is strictly less than -1. Now, if you want to impress me, pause this video right now and go solve it, and then see if I did it correctly. That was your cue to pause it. Okay, I'm going to keep going. So there are two possible solutions. The first one is where it's all positive inside of this. And I know I didn't do a test case on that last one like we should do, right? Here, let's do a test case. Let's plug in x equals 0. Just back up to this one. What is -5 times 0? 0. What is 0 plus 8? 8. What is the absolute value of 8? 8. What is 8 plus 2? 10. Is 10 less than 25? Yes, it is. So that one test case that I just picked out of the infinite choices verifies that, well, yeah, looks like I didn't screw up this time. All right, back to 1E. Two possible solutions. The first one is to treat the absolute value as if it were a positive quantity inside of that. Think of it as replacing it with parentheses. Parentheses, x plus 5, close parentheses, is strictly less than -1. Now, go solve for x. Parentheses aren't doing anything here. So my next step would be to subtract 5 from both sides. The left becomes x. Again, addition or subtraction, not going to change the orientation. So it's still strictly less than. -1 minus -5. Quick, what's that? 4. Are you sure? -1 minus -5. That's 4. Not -6. -1 minus 5 would be -6. -1 minus -5 means you're subtracting the negative, which means you're adding the positive, which means -1 plus positive 4. There you go. So we're already at a solution. It says x is strictly less than 4. On my one-dimensional number line, when I go to 4, I draw with an open circle because it says strictly less than. If it said less than or equal to, I would fill in the circle and make it a dark circle. But this one says strictly less than. Now that's only one end of the solution space. We need to go find the other end. To find the other end, we treat everything inside the absolute value symbol and sign as if it were a negative quantity. And so I'm going to write it with a minus sign. And instead of writing absolute value, I'm going to write it with parentheses. Don't change the interior expression, x plus 5, close parentheses instead of absolute value symbol. Still strictly less than -1. Great. Solve for x. I would use the distributive property first because I'm like, well, you know what? Let's do something easier. This is -1. That's -1. You love negative numbers. Well, why don't we divide both sides by -1? That sounds like a good idea. So the left side becomes x plus 5. Now, can you think back? I don't know, what, 2 minutes? When we divide by a negative number, we have to reverse the inequality. So if it was originally less than, when we divide by a negative number or multiply by a negative number, it reverses orientation. So less than becomes replaced with greater than. And we're just dividing both sides by -1. So -1 divided by -1 is 1. Now we finish solving for x. I would subtract 5 from both sides. X is strictly greater than, quick, what is 1 minus 5? -4. Okay, good for you. So x is strictly greater than -4. So I go back to my one-dimensional number line, and I'm going to graph it now with an open circle at x equals -4. The two solutions are x is strictly less than 4, and simultaneously, x is strictly greater than -4. So I guess if I were to, mark it graphically, I would have a open-ended, open circle-ended number line that spans from -4 to +4. And graphically, I could say x is strictly greater than -4, strictly less than +4 as the solution for it. Now, it's always a good idea to at least plug in one test number and see if it works. So let's plug in 0 because it's so convenient. 0 plus 5 is 5. Absolute value of 5 is 5. Is 5 less than -1? Think about that. Is 5 less than -1? No. In fact, in a previous video, I hit the same problem. Here it is written in the book. Absolute value of, and I can zoom in ever so slightly because I know that is one of these buttons, that one. The absolute value of the expression x plus 5, strictly less than -1. Well, the thing of it is, absolute value can never be negative. It can be 0, it can be greater than 0, but it can never be less than 0. So under no conditions, for no values of x, would this relationship become true. A positive number, or 0, can never be less than a negative number. So what we would say for letter E, despite all this great work I just did of trying to teach you how to be successful with math, what you need to do is say basically no solution. And I think on that sad note, I should try to stop teaching you how to do this stuff for tonight. All right. So this is help for Math 2 Spring, Week 1, Day 1, Homework 1, where on the skills practice or something, they expected me to have gone over this material with you before I assigned the homework. Ha! Good luck.